Welcome to solverfy.
All right, so here we're using two different sorting algorithms to sort a list. So we have 7, 4, 3, 8, 1, 5, 4, and 2. Okay, so first we're going to use the insertion sort. So we will grab the second element of the list and ask ourselves, is it larger than 7? So is 4 larger than 7? The answer is no, so we're going to insert it at the beginning. So that's going to give us 4, 7 for our sorted portion, and 3, 8, 1, 5, 4, 2 as the unsorted portion. And that took one comparison for the first step. Then we're going to do the same thing. We'll take the 3 and say, is 3 larger than 4? And the answer is no. So that gives us 3, 4, 7 sorted portion, and 8, 1, 5, 4, 2 for unsorted. And that again just took one comparison. So we'll grab the 8 and say, is 8 larger than 3? Yes. Is it larger than 4? Yes. Is it larger than 7? Yes. Okay, so 3 comparisons, all to find out we didn't need to move it. And so our list is 3, 4, 7, 8 for the sorted, and 1, 5, 4, 2 unsorted. And then we'll do the same thing. So is 1 greater than 3? The answer is no. So I'll give us one comparison, and we can put the 1 there. So we get 1, 3, 4, 7, 8, and 5, 4, 2 left. And so we'll grab the 5 and say, is 5 greater than 1? Yes. Is it greater than 3? Yes. Is it greater than 4? Yes. Is it greater than 7? No. Okay, so that was 4 comparisons. And now we can insert it here after the 4. So 1, 3, 4, 5, 7, 8, and 4 and 2 remaining. So we're getting near the end here, so grab this 4 and say, is it greater than 1? Yes. Is it greater than 3? Yes. Is it greater than 4? No. Okay, so that took 3 comparisons. So we can insert that. And we just have one value remaining, and so that's the 2. And so we'll take the 2 and say, is it greater than 1? Yes, it is. And is it greater than 3? No, it is not. So that took 2 comparisons. So that'd be 1, 2, 3, 4, 4, 5, 7, and 8. And so if we tally up the comparisons at every step here, we get 15 of them. So then we'll do the same thing here for the binary insertion sort. And the difference is that we're going to be using the binary search algorithm in the sorted portions of our list. So if we start with perhaps a new page is a good idea. So we'll start with our list of 7, 4, 3, 8, 1, 5, 4, and 2. And so it's going to start out the same way, where we compare 7 and 4 to get one comparison. And it starts us off with 4, 7, 3, 8, 1, 5, 4, 2. Okay, so now what's going to happen is when we want to start comparing the 3, we're going to use the binary search algorithm. So what that involves is saying, well, we want to take index 1, add it to index 2 for 3, divide it by 2 for 1.5, take the floor of that, so round down for 1, and that's what we want to compare the 3 to. So we'll ask ourselves, is 3 is 3 greater than 4? And the answer there is no. Okay, so because that's just the one comparison in order to be able to insert it. So it's 3, 4, 7, 8, 1, 5, 4, 2. Okay, so this time we're taking the 8, but we want to do the same thing. So we're taking, to find what we're going to compare it to, we'll take index 1, add it to index 3. Right, it's going to be a total of 4. Divide that by 2. It's going to give us 2. So we want to compare 8 to index 2, which is the 4. So we ask ourselves, is 8 greater than 4? Well, the answer is yes. Okay, so then that's going to move the index we would compare it to up 1. And so then we're sort of left with only being able to compare it to the 7 here. So there's no more splitting things in half. So there's just one element remaining. So we'll ask ourselves, is 8 greater than 7? And the answer is yes again. So that took 2 comparisons in order to put it in its place. So 3, 4, 7, 8, 1, 5, 4, 2. Okay, so then we'll take the 1. And we're going to do the same thing here. So we take our range of indexes, this time it's 1 to 4, add them up to get 5, divide by 2 to get 2.5. We want the floor of that, so we're going to compare it to the 4 here. And so then we ask ourselves, is 1 greater than 4? And the answer is no. So we reduce our range of the list that we're interested in, but that only leaves the number 3. There's only one value left here, so there's no more divisions, and we can ask ourselves, is 1 greater than 3? And the answer is no. So that took 2 comparisons to be able to know we need to insert it to the left of 3. Okay, then we just have these 5 elements left. So we're going to do the same thing. We'll grab the 5 here. And in this instance, we're going to compare it to the 4. So we say, is 5 greater than 4? The answer is yes. That restricts our range to this latter half, the 7 and 8. But when we do the math here, we're going to end up comparing it to the 7. So we'll ask, is 5 greater than 7? And then the answer is no. Okay, so we got a greater than 4 and a not greater than 7. So it took 2 comparisons to be able to put that in its place. Okay, and then we just have these last 2. So the same thing, we'll grab the 4. First, we're going to end up comparing it to, and so when we do the arithmetic, we'll end up at this index in the middle here, but we floor down, so we're going to compare 4 to the 4. We'll say, is 4 greater than 4? Well, the answer is no. So then we end up moving to the next set here. And then so then we'll ask ourselves, is 4 greater than 7? The answer is no. And then we'll compare it to 5. And the answer is no. So it took 3 comparisons here to put 4 in its place. And that just leaves us with 2. And so we'll grab the 2. First, we're going to end up comparing it to the 4. From there, we'll end up reducing our range to the first 3 elements. We'll compare it to the 3. And then there, we'll know where to insert it. So that's going to give us 1, 2, 3, 4, 4, 5, 7, 8. And that was 2 comparisons. I apologize, that's going to be 3 comparisons. So we compare to the 3 and then compare to the 1. Okay, so when we total these up, this is a total of 14